The sun sent a signal. It wouldn't stop. On August 21st, 2025, NASA's Solar Monitoring Network picked up what appeared to be a completely ordinary event. A radio burst from the sun. Scientists see these all the time. They flicker on, broadcast for a few hours, maybe a couple of days, then fade. Routine, forgettable, not worth losing sleep over. This one didn't fade. Day 3 passed, then day 5, already matching the all-time record. Then day 7, day 10. The instruments kept logging the same signal, steady and strong, as if the sun had simply decided it had something to say and wasn't finished saying it. Buried somewhere in that data was a clue about what the sun does right before it fires its most dangerous shots at Earth. Scientists just didn't know it yet. On day 8, one researcher pulled up the raw numbers and checked the equipment twice. The signal was still there, still broadcasting. Nobody had ever seen anything like it. By day 19, it finally stopped, and the questions started. Type 4 solar radio bursts are produced when clouds of high-energy electrons get trapped inside the sun's magnetic fields. Think of it like a particle accelerator wrapped in a magnetic bottle. The electrons spin, they radiate, they broadcast radio waves outward into space. The radio waves themselves are harmless. They pass right through you, right through your house, right through the planet without anyone noticing. But the magnetic conditions that create them are a different story entirely. Those same conditions are what the sun uses to build up pressure before a major eruption. That was the first thing that made scientists nervous. And then they started asking the real question: what on Earth, or rather, what on the sun, could possibly keep that magnetic bottle intact for 19 straight days? The answer required 4 separate spacecraft and a method that had never been tried before. NASA's stereo mission, the Parker Solar Probe, the WIND spacecraft, and the joint NASA-ESA Solar Orbiter were each positioned at different points across the inner solar system in August 2025. None of them observed the entire signal. Each one caught a few days of it during overlapping windows. Researchers stitched those observations together like pieces of a puzzle, and when the full picture emerged, what they found was extraordinary. The signal wasn't coming from the sun's surface. It was coming from far above it, from a massive magnetic structure called a helmet streamer, towering between 6 and 10 solar radii above the solar surface. To put that in perspective, one solar radius is roughly 430,000 miles. This structure was sitting between 2.5 and 4 million miles above the sun, extending outward into the corona like an enormous magnetic arch. Its width alone spanned nearly 1.3 million miles. Let that sink in. But here's what the researchers found when they looked closer at those 3 solar eruptions that occurred during the signal, and this changes everything about how we read the sun's behavior. A signal like this cannot sustain itself on stored energy alone. The physics don't allow it. Trapped electron populations decay. The magnetic bottle eventually leaks. In every previous Type 4 burst on record, that decay took hours, days at most. Something was actively recharging this one. The researchers identified 3 separate coronal mass ejections, 3 distinct solar eruptions that fired from the same region of the sun during those 19 days. Each one sent a fresh wave of energetic particles streaming into the magnetic structure. Each wave replenished the electron population inside the helmet streamer, resetting the clock, extending the broadcast. The sun wasn't just passively emitting a signal, it was actively maintaining one, reloading it, keeping it alive through repeated eruptions from the same unstable region. The same unstable region that was pointing more or less toward Earth. Think about what that actually means. For 19 days, a section of the sun's atmosphere the size of several Earths was in a state of sustained magnetic instability. It was erupting, recharging, erupting again. And those coronal mass ejections, those are the things that knock out satellites, that scramble GPS, that can overwhelm power grids in a Carrington-level event. The signal was the warning. We were watching a lit fuse. We just didn't fully understand what we were watching until the paper was published in May 2026, 9 months after the event. Here's where it becomes personal. Right now, somewhere between 700 and 900 active satellites are providing the GPS signal that your phone uses every time you navigate somewhere. Another few hundred manage global communications, financial transactions, weather forecasting. If a major CME from a sustained recharging magnetic structure like the one from August 2025 hit Earth directly, The damage to those systems could range from temporary disruption to permanent loss of hardware in orbit. The Carrington event of 1859 occurred before any of that infrastructure existed. Telegraph wires caught fire. That was the extent of the damage. The same event today would be categorically different. What this discovery offers, for the first time, is a potential early warning mechanism. Long-duration Type 4 bursts, signals that persist for days rather than hours, may indicate exactly the kind of sustained recharging magnetic instability that produces the most dangerous CME sequences. If scientists can recognize that pattern in real time and not just in hindsight, they could give satellite operators, power grid managers, and aviation authorities days of warning instead of hours. That's the part that matters. Not just that the sun did something strange, but that the strangeness itself might be a message we can finally learn to read. What remains unknown is whether this kind of 19-day event is rare or simply underreported. Before this study, no one had developed a method to stitch together multi-spacecraft observations into a continuous signal timeline. Every previous record might have been artificially short, not because the bursts faded, but because no single instrument watched long enough to catch the full duration. The sun has been talking. We've only been listening in fragments. Remember that clue mentioned at the beginning, the one buried in the data about what the sun does before it fires its most dangerous shots? That clue was the signal itself. A sustained magnetic reservoir, reloaded 3 times over 19 days, pointed in our direction. The sun wasn't malfunctioning, it was operating at full capacity, and we had no early warning system capable of recognizing what that meant until after the fact. The question worth sitting with isn't whether this will happen again. It will. The question is whether we'll recognize it in time. What do you think? If scientists confirmed a 19-day solar eruption sequence aimed directly at Earth, would you trust our infrastructure to survive it?